All right, so there's our warm-up we did. It's like yesterday's warm-up, okay? Now, we know this. We're going to take out the headphones. I'm going to tell you just once. It's going to be a nice day. We're going to get through this faster than normal because I'm not going to have to tell you multiple times, right? Right? And we should never have 2 headphones in because that's a school rule. And we should have 0 in right now because we're doing notes, right? Right? No. Not 1. Oh, okay. All right, here we go. So, looking at this, right? So, 3.2 notes. We did 3.1 notes, and that was for linear. The warm-up we did today was linear, okay? And now we're doing quadratic. Move it down just a little bit. There we go. All right, quadratic. So, y'all know quadratic looks like this. F of x equals x squared. Right there. And y'all have seen this before. What's this called, this graph right here? Parabola, okay? It's a quadratic, and it makes a parabola shape, okay? Now, square root. So here's the deal. If I find the inverse of x squared, I get square root. Does everyone know that squaring and square root are opposite things? They cancel each other out? If you didn't, hopefully now you know. Square root, they're opposites. Now, can you see right here in the graph that it's kind of just this one flipped kind of sideways, right? But it's only half. And that's going to matter today. You're only doing half. And I'll show you why in a little bit. So what I want you to do at the bottom here is graph just the right side of this. So I want you to graph these 3 points down here. Okay? And then graph these 3 points down there as well. Okay? You'll notice the top of this table, right here, it says NA. So let's just plot those 3 points here. So 0, 0, 1, 1, 2, 4. 0, 0, 1, 1, 2, 4. Whoops. So you make kind of your curve like that. And then, for the square root of x, 0, 0, 1, 1, and this time it's 4, 2. It's going to go like that. Okay? These are, what do you call it? Symmetrical across the line y equals x. Okay? All right, so graph something like that. You got half a parabola. Okay, so you can flip it over to the back. Let's do some examples together. It's going to be very similar to the linear, except we're going to do it with quadratics. Now the big difference is going to be the step where we get rid of a square. So let me show you how it's done. This is new, so everyone's paying close attention, right? All right, so you know how to solve this. We just did this on the warm-up. What's my first step when I'm solving the equation? F of x becomes what letter? Y. Let's write that down. Everyone's doing this. Y equals x squared minus 3. Now, second step, what do I do with x and y? Switch the places of x and y. So it's going to be now x equals y squared minus 3. Okay. X equals y squared minus 3. Now, if I'm solving for y, that minus 3's got to go. That's the loner. How do I get rid of a minus 3? Add 3 to both sides. So plus 3 here, and then on this side, plus 3. Now what's x plus 3? Is it 4? Is it 4x? Is it 3x? Is it... Just like I said. So x plus 3 is x plus 3. So x plus 3 equals what? Equals y squared. Now, here's the new step. How do I get rid of the squared? Look over here. How do I get rid of a square? What's the opposite of squaring something? Square root. Opposite of square? Square root. So that square root sign symbol. So, here's what you're going to do. When you're left with a square, you're going to do a square root on one side and a square root on the other side. Okay? All the way over the x plus 3. Okay? No, I'm showing you how to get rid of the square right now. To get rid of the square, you have to do square root. So the square and the square root go away, and now I have square root x plus 3 equals y. Yay! Last step. Instead of y, it needs to be what? F inverse x. Write this down. With what pencil? Okay, so I'm going to write f inverse x equals square root x plus 3. Ta-da! So it should make sense. Your original has a squared, and your new one has a square root. So here's where this is a little different, okay? When we do these, we only want part of the parabola that's going to flip over, okay? So I want you to notice this right here. There's a domain, there's a restriction, okay, on our graph. So whenever you're doing your table, I want you to start off with the vertex. So first of all, let's graph this thing. The original graph is x squared minus 3. Let's go to our calculators, go to new document, go to graph, x squared minus 3. Now where's the vertex? You can see it right here. What's this point right here? But the coordinates are 0, negative 3, right? So what we want to do, the first point on our table is going to be 0, negative 3, right? So let's hit Control T so we can see the rest of our table. And again, all I want is from here to here. I want the right side of my graph because when it flips over, I'm only going to have the top side of the square root. All right, so 0, negative 3, 1, negative 2, 2, 1, 3, 6. Let's put those 4 points down, which is the vertex. 1, negative 2, 2, negative 1. Nope, that's 2, 1. And then 3, 6. Go ahead and plot those 4 points off to the right, please. It's going to be just the right side of the parabola. 0, negative 3, 1, negative 2, 2, 1, 3, 6. Try to make it curvy. Now, if you have your original, how do you get the inverse? What do I do with this table? It's like the warm-up. We flip the table. So let's flip it. Does everyone see that the domain is correct? It goes from 0 to infinity. It starts at 0 and it goes to the right forever. So when we do our inverse, we're going to see on the graph what's the domain. So what's my new table going to be? What goes first? Negative 3, 0. Negative 2, 1. 1, 2. And 6, 3. Now plot those points, and it should look reflected across the diagonal line y equals x. So, negative 3, 0. Negative 2, 1. 1, 2. 6, 3. Ta-da! Now, it's kind of not the best graph, but that reflects across y equals x, right? Cool. Now here's the last question there. What's the domain of that blue line? So you want to think left to right. How far to the left does this blue line start at? What's right there? Yeah, this point right here is negative 3. So I'm going to start with a bracket including negative 3. And doesn't it go to the right forever? So what am I going to put? Infinity. So this is called a restricted domain for the original function because only part of the original gets reflected. The right part of the parabola gets reflected. All right. Now, you get the idea, right? The only thing that's going to be a little different is going to be if there's parentheses, there might be a few different step orders of the step, okay? So let me show you what I mean. Number 2, or the second one. Example 2. What do I do first with this f of x? What letter? Change it to a y. Okay. Second step, x and y do what? Switch places. So x equals, parentheses, y minus 4 squared. Now, last time, up here, I got rid of this loner first. But this time, it's stuck inside parentheses. So what do you think I should do first? Not divide. Not subtract or add. So the first thing that's got to go, since there's parentheses, is the squared. So everybody, when you see one like number 2, when you see a squared outside of parentheses, you're going to have to square root first. Okay? So, check it out. Big old square root on both sides. Square root, square root. Because there's parentheses and the squared outside those parentheses. Right? Now, on the left side, it's going to stay square root of x equals, the square and the square root cancel each other out. So we're left with y minus 4. That's it. Okay? Now, how do I get rid of this minus 4? What's the opposite of minus 4? Plus 4. Now here's one of those situations where people goof up. Square root of x plus 4, is that 5? Is it 4? Is it square root of 5? Is it square root of 4? Is it 4 square root of x? Is it square root of 4x? None of the above. Okay? When you have a square root of x and then you add a 4 to it, it just goes right next to it. Here's what I mean. Square root of x and then plus 4. Just put it next to each other. Okay? Equals, that cancels out, y. I want you to see with your own eyes the difference. The very first one, the square root went all the way over everything. This one, it's only over the x. The plus 4 goes after the square root sign. Okay? Now, last step, it needs to be written like inverse. So, final form, f inverse x equals square root of x plus 4. And the plus 4 is after the square root sign. There is a difference if it goes across the whole way or if it's only part of it, okay? Can we do the table and the graph just like we did before? Who said no? All right, let's do it. X minus 4 squared. Let's put that into our calculator. Now, I'm going to do the kind of cheater way. I'm just going to hit tab, and I'm going to go up. I'm just going to retype it in. Either way works. So let's do parentheses, x minus 4 squared. Ta-da! Now, where's my vertex? Not 0, but what's the x value? 4, 0, okay? So what I want to do is find my vertex on the table, 4, 0. And I'm going to use the points to the right of it, okay? Only the right part of the parabola is what I care about, okay? So forget the left side. So let's write these points down. 4, 0, 5, 1, 6, 4, 7, 9. And plot those points for me, please. 4, 0, 5, 1, 6, 4, 7, 9. As Miss Burrow says, woo. And you know how to get the new table? Flip X and Y, plot the new points. What's behind this? Could it be the other one of those? I think it is. It is. I knew it. I knew it. Okay. You want that? Check out this trick. No, kidding. All right. So, let's flip it over. 0, 4, 1, 5, 4, 6, 9, 7. All I did was switch the order, right? Can you take it out? Please. Please. I have a notification for you. Take it out. All right, let's plot these points. 0, 4, 1, 5, 4, 6, 9, 7. Does everyone see how that reflects across the diagonal line, right? Now, what's the range of this blue line? How far to the left is this point right here? What is the x value? 0. Now, some people tell me 4. I'm talking about x. You go straight down, it's 0. And it goes all the way to the right, which is infinity. So 0 to infinity. Okay, now I know this can be kind of not the most exciting thing in the world, but let's do one more and we'll be done. Sound good? Yes. All right, example 3. Now, do you see how this one's even different than example 2, right? So this one has a parentheses and a number after it. But we can do this. So let me show you what to do. First step, f of x turns into a what? Y equals minus 2, yeah. And then x and y are going to do what? Switcheroo, right? So x equals boo, as Miss Ferrero says. Boo-hoo. Now, I need to solve for y. This is different. Do you think I should get rid of the 1 first, the squared first, or the minus 2 first? What do y'all think? The minus 2, the loner, okay? So we will get to the square root next, but the minus 2, the big loner's got to go. What's the opposite of minus 2? Plus 2. Now, x plus 2, is that 3? Is it 3x? Is it 2x? None of them. X plus 2 is x plus 2. Right? So, x plus 2 goes here. And then we got parentheses y plus 1 squared. Now, just like last example, example 2, how do I get rid of the squared? Square root. All right, so to get rid of that square root, square root. The square and the square root cancel out. Goodbye. So now I have a big old square root of x plus 2 equal to y plus 1. What's my last step to get rid of that plus 1? The opposite of plus 1, minus 1. Now, once again, the minus 1 is not combining. It's just going to be right there afterwards. So let me show you. This one's kind of weird. I'm going to put my final form here. The inverse of x equals, the first thing I'm going to write is square root of x plus 2. And then after that, I'm going to put minus 1. Do you see how the minus 1 is not under the square root sign? It's after the square root sign. Okay? It really does matter how far your square root goes. So make sure you're putting what needs to be under the square root, under the square root. Okay? Okay, now we know how to get the tables and graph it. So let's do that real quick. X plus 1 squared minus 2. Go to my calculator. Is it minus 2? Yeah. Now where's that vertex? The x value is negative 1. The y value looks like negative 2. Let's find out. Is it negative 1, negative 2? By golly, it is. Let's put these 4 points. Negative 1, negative 2. Zero, negative 1, 1, 2, and then 2, 7. So once again, this is my vertex. Same thing up here. Goodness gracious. This was my vertex. Anyways. Alright, plot those points. Negative 1, negative 2, 0, negative 1, 1, 2. Whoops. Big whoops. And then 2, 7. So for the inverse, we switch them. Negative 2, negative 1, negative 1, 0, 2, 1, 7, 2. Plot those points. Negative 2, negative 1, negative 1, 0, 2, 1, 7, 2. And once again, it should be symmetrical across across y equals x. By the way, that vertex, what's the x value of this inverse function? Negative 2 with a bracket up to infinity, goes forever to the right. Okay. So as you're getting that down, I'm going to pass out the assignment that you'll have a little bit of today and then tomorrow to finish. All right.